So I'm just here to give quite a high-level overview to the room on the situation, the Myrtle Rust situation in Western Australia. As most of you have probably heard, it's been a little bit in the media that we have detected Myrtle Rust for the first time in Western Australia. So just here to answer any questions and tell the story. And just quickly, so I'm Myrtle Townsend. I'm now with the Dieback Working Group, and I just want to acknowledge that a lot of the content from these slides and photos and so on came from the Department of Biodiversity Conservation and Attractions and Kylie Island and her team over there. I'd like to acknowledge country, acknowledge the traditional custodians of the lands on which we're meeting today, as well as the Miro and Gudgerang traditional custodians of the East Kimberley, where this presentation takes place. And I'd like to pay my respects to elders past and present, and to the thousands of First Nations people undertaking such a vital role in the management of Myrtle Rust, because we've heard so much about it, and it's just a really important part of what we're all aiming to do. So Myrtle Rust was detected on the 29th of June in 2022 in a remote station in the Kimberley. It was detected during some targeted surveillance efforts that people at DBCA and people from QDAF, Jeff Pegg and others had helped to coordinate and drill down into where the pathogen was likely to have come across from the Northern Territory, according to potentially vulnerable species and wind patterns and so on. This slide is obviously fairly low resolution, but the little red dots show over in the Northern Territory where the nearest Myrtle Rust infestations are, and you can see the green dots down across the Western Australian border are the sites that we targeted with surveillance, and you'll see the one red spot there where we found the positive infestation. So Myrtle Rust was detected at just one site. This site is part of a priority ecological community called Organic Mound Springs. These ecological communities are found primarily in the Kimberley region of Western Australia, and they're basically sites where the groundwater will well to the surface, creating like a wetland type ecosystem in the middle of a mud flat. So they're islands of suitable microclimates for the pathogen. They support distinct assemblages of aquatic invertebrates and stygofauna, so something to think about in terms of fungicides and so on. These slides that I'm about to show are some photos from the site where we detected Myrtle Rust in Western Australia. So you can see it has been recently burnt. You've got regrowth after fire on the Melaleuca leucodendra, which in some of the susceptibility trials run over here has been documented previously as susceptible to Myrtle Rust, and quite open and sort of very humid microclimate in there as well. And these are some photos of the expression of the disease at the site. So very textbook photos. We found it on two species, as I said, Melaleuca leucodendra and also Melaleuca ulcifila, which is more narrow leaf Melaleuca that is a far sort of tougher leaf than the leucodendra. So that was in 2022. Because it was just detected at one site, and we did make over 200 negative Myrtle Rust observations on susceptible species, we decided that the most appropriate course of action was to take a look at what was going on at the same site, IP1 and surrounding areas in 2023. There's very little known about how the disease spreads or behaves or the vulnerability of species in those northern dry tropical climates. So in 2023, some repeat surveillance was done, very similar site distribution to 2022. It was staffed by a group of people from Department of Biodiversity Conservation and Attractions, the Forest Products Commission, Kings Park Botanic Gardens, and Department of Primary Industries and Regional Development. They revisited the previously 6 positive subsites at the initial infested premises and sites to the west as well as high-risk sites in Kununurra and surrounds. And this is just showing the key differences between the surveillance efforts between the years. So there were some slight differences in the amount of effort put in, but the interesting things to learn was that there'd been quite a bit of recovery since fire in the 1 year since accessing the original site. And so the expression of the disease was lower incidence and lower severity as well. And these are some photos just to contrast to the ones that we saw earlier of, what the disease looked like. Some evidence of older lesions as well, and just a few more there. So the way that we manned the response in Australia was quite collaborative. Due to some complexities with legislation and so on, it ended up that the response was advised through a multi-agency working group. We had representatives from a variety of sectors, including government, industry, community, research institutions, and then Jeff, and Plant Health Australia as well, providing technical advice. I think that it's important to note that there are some advantages to a collaborative response like this. If it's done properly, it can be very empowering for a large range of stakeholders. And it can, as we saw from the way that the surveillance efforts were manned, it can mean that you have more access to human resource availability and good engagement. But disadvantages can look like a lack of clear leadership and definitive responsibilities, particularly in the areas of funding. So, based on what we've observed in the Kimberley, the goal for Western Australia remains to basically watch and act, but to keep myrtle rust out of the biodiverse southwest. So these Climax suitability maps are quite dated now, but they still basically draw the picture that the southwest of Western Australia is highly suitable for the pathogen. And those stats on the right-hand side showing the number of species of Myrtaceae in Western Australia is over 2,000. 1,500 of those are native to WA, and over 1,000 of those are from the southwest bioregion. So it's a huge amount of diversity, a huge amount of short-range endemism within that biodiversity hotspot. So several of these species could be very vulnerable, particularly with what some of Alyssa's research is showing with low resistance in some species. The good news is a wind pathway into the southwest is highly unlikely. So we're really looking at human vectoring as being the main course of transmission for the disease into the southwest of WA. It's just a lucky thing with the way the wind patterns are. So some ongoing strategies for how we're managing that human risk vector pathway is through ongoing surveillance. Obviously, early detection gives us a higher chance of potential eradication, or if not eradication, then proactively directing some of our preparedness activities. We've heard a lot today about how getting onto germplasm collection for vulnerable species early is really important. Spore trapping could be a way of directing on-ground surveillance, but citizen science is proving to be a really important tool. We've got the My Pest Guide reporter as a key tool that we're using to get people to report biosecurity risks of any nature. So this is also a massive thing in our favour for the polyphagous shot-hole borer response that's currently underway. And then continuing to look at preparedness. So I think that we need some really clear and agreed upon rapid response plans, as we heard about for Lord Howe Island, and working arrangements between agencies in place for the southwest, for if and when we find that myrtle rust incursion, and continued germplasm collection as well. And if I have time, there's a short video on what's currently underway in that space in this presentation. And communication and capacity building. So, last year we had the tremendous biosecurity blitz run through DPIRD, and it showcased 5 priority pests of trees, and including myrtle rust, and was really pushing what those pests look like and trying to get people to report them proactively. Training and capacity building within Western Australia is difficult because we don't have myrtle rust to look at. We have been fortunate enough to come over just earlier in March to do some Queensland training with Jeff. We had 9 participants from a group of agencies come and look at identification in the field, including analogous species to what we see in WA, and some cryptic and atypical symptoms as well. One of the ways we're pushing hard to get that message out there is something called the green card training. This is an important tool that we're using in WA to, it speaks a lot about Phytophthora dieback, but that consistent biosecurity messaging around arrive clean, leave clean is important across most biosecurity threats, and it's also a good way to get the myrtle rust images out there. So that green card training has a myrtle rust module embedded in it now. The primary audience for Green Card is industry, but that's good because industry has a lot of boots on the ground. And just, a massive success and where collaboration can be really powerful. Recently, an online version of Green Card was launched in collaboration with Western Power. And we've had nearly 2.5 people complete their Green Cards since February. So that's been a huge push for getting the word out there. We have plans to expand the program further to other utilities within Western Australia and broader as well. We're partnering with a group down in Albany called the Binlup Aboriginal Corporation, whose main focus is capacity building within Aboriginal ranger programs throughout the southwest to get the word out there in that regard. This is the germplasm collection. Do we have sound? We don't. That's all right. This is available on YouTube if you Google DBCA on YouTube, and it's a very short video around what's going on in the germplasm collection space. Basically, there's been some really concerted efforts from Kings Park and Amanda Shades here today as well, if anyone feels like asking Amanda any questions, to try and collect some of those species in the Kimberley. Was it 55 species at last collection? Yeah. So that is an exciting part of what we're doing. Obviously, it's very difficult. Some of the susceptibility testing is helpful for directing those efforts, but without seeing the impacts that myrtle rust is having, it's difficult to prioritise. So that's sort of a space that we're thinking in as well. Planned and potential actions. I think it's important that we do some strategic planning, some response planning for Southwest WA, including relative responsibilities, a rigorous communication strategy since we do have that human pathway, and just a real concerted effort and lead time and investment for engagement and participation with traditional owner groups. In the Kimberley, most land is joint managed, so there are a whole range of ranger programs up there that are on the ground all the time and are a really powerful tool for biosecurity. So that would be a fantastic space to build some capacity. And continuing all of this with guidance from the WA Myrtle Rust Working Group. There's also an exciting PhD underway with 4 research priorities. A poster that Eric's developed is in the main area if you haven't seen it already, but it's basically his research proposal that will start to explore the epidemiology of the disease and some of the ways that it's behaving in those northern dry climates. Okay, that's it from me.
Wait. Any questions? Yeah. Who's got the mics? That was really interesting because I spent a few months living in the East Kimberley chasing cane toads about 15 years ago.
Oh, yeah.
So that was a blast to the past for me.
And the cane toad messaging and the myrtle rust messaging really go hand in hand. So some of those, pathways is something that we're looking at utilising as well for getting the word out there.
Cool.
Can I just ask, with the Melaleuca leucodendra that was sampled up in East Kimberley and found to be have myrtle rust, were there any signs of tree death or defoliation?
No, and the infection was also very localised. So we could see, we had Louise Shuey with us at the site, and we could see evidence that it was repeat infection. It could have been from one season, because obviously you can get multiple infections within one season, but that's impossible to tell. And there was a small amount of sort of singeing of the leaves, I suppose, and so on, but it really just seems that the disease is kind of ticking along without having a huge amount of impact, touch wood. And very localised as well. So we're looking at a wetland type environment. The microclimate over the water seems to have the right kind of humidity conditions for the rust. But as you get back into the drier parts of the swamp, we didn't observe any myrtle rust. So
That's encouraging because Melaleuca leucodendron's even more of a keystone species than Melaleuca quinquenervia.
Absolutely.
Really interesting. And I love the idea about the tremendous biosecurity blitz. What was the messaging that you had afterwards? Like, once you got the results, did you have community outreach telling people about what you found?
Different department to the one I was in, so I'm not actually sure on that one, but not that I have observed, which it would be an interesting sort of feedback loop to, then feed that back to people and potentially encourage more reports into the future.
One more.
Thanks.
So the East Kimberley wasn't identified as a suitable site according to the climate modelling. I guess if I play the devil's advocate, I can say, well, how useful is modelling in identifying sites to focus monitoring? And are there lots of other isolated sites that might be infected as well?
I have met many devil's advocates in this space, and look, I think that it is important to note that we're not at panic stations yet, because, as you say, it's quite a remote area. It doesn't seem to be doing a lot, but the Kimberley, and particularly, well, the West and East Kimberley, is a very popular tourist destination, and a lot of those microclimates, like the gorges, are the highlights for tourists, and the main pathway of anthropogenic spread is into southwest WA. So while identifying each and every remote site where Myrtle Rust is might not be the best way to be directing our resources and energy, certainly we should be keeping an eye on some of those sites that are accessed by people to make sure that we're minimising that potential human vector into the southwest. Yeah.
Sorry, can I just say something? Is Robert Park here still? No. Because I know that there are cases, I know you say it's not really doing a lot of damage at this point in time, but I know that in the cereal rust there are cases where you have something that seems fairly static for a very, very long time, and then something changes and it suddenly becomes a massive problem very quickly. So I think we've just got to keep that in mind.
I agree. I don't think we can be complacent. Yeah. It was a perfect combination of factors where we found the rust with the recent fire, and we went to so many other sites, and Louise and I were sort of walking around and saying, if I was a Myrtle Rust, I would love it here, because there were beautiful new growth syzygiums, but there hadn't been fire. So it's interesting, but certainly things could change, and I don't think we should get complacent. So.